Here's our second handout from this week. How are three or more angles related? We're going to be talking about what happens when you have lines that cross, which is an intersection. So angles are formed or made when two lines intersect. Intersect just means they cross, kind of like when you're driving. If you have an intersection, you have two roads that come together somehow. So a vertical angle, technically vertical angles, they have to be a pair of angles. They are across from each other or opposite each other. At an intersection, and they have the same measure. And part of the reason this is, if you can think about it, if I had these two lines lined up, and then I hold that middle point still and I rotate it, or either way, if I rotate this one a certain amount of degrees, I'm going to be rotating it the same amount this way as that way. And so these two angles that are formed across from each other are going to have the same measurement. And you can kind of see that. You can kind of think about, well, if I were to pick this shape up and spin it around 180 degrees, this shape over here, the angle D, would line up exactly with the shape of angle B on the other side. Same with angles A and C. They're across from each other. You can tell that they're kind of about the same shape. So the vertical angle pairs in this figure are A and C. They're across from each other. I'm going to write that angle A and angle C are across from each other. And angles B and D are across from each other. What that means is if I were to know how much angle B measures, I could know how much angle D measures, and vice versa. If I know the measurement of angle C, I know the measurement of angle A, and vice versa. So that's useful information. Adjacent angles, on the other hand, that just means they touch. They share one ray. It's like they're next to each other. So if I look at this ray here that starts in the middle and goes to the right, the two angles that have that ray are angle A and angle B. So those are adjacent angles. You can have other angles adjacent to A. There can usually be, there's usually one on each side of it, right? So the only real thing that this is useful for is if you're trying to figure out, if I know the measurement of one of them, and if I can find like a straight line, or if I can find a 90-degree angle someplace, and there's two adjacent angles, then I'd know based on the shape they make together whether they're complementary or supplementary, and that'll help you solve it. The angle pairs that are adjacent are angles A and B. Oops, that's supposed to be an angle symbol. B and C. C and D. And D and A. Now it says, let's say that A's got a measure of 110 degrees. I'll write that next to him. Determine the measure of the other angles. Now they're listed alphabetically. The measure, that little M means a measure of angle B, measure of angle C, measure of angle D. I'm going to go ahead and get C because these vertical angles, that means that C also has to be 110 degrees. There's no other way. So I'm going to go ahead and write it down. There. Now let's figure out angle B. If I take some paper, let's see if I've got a nice piece of paper I can get to. Nope, not really. I use on my other sheets. I usually tell the kids, look, if I can ignore some of the angles and just focus on one thing I know and the one thing I don't know, at this point in the game, usually, you'll be able to find either a right angle or a straight angle. Right now, I've got this straight line here, which means these two angles add up to 180 degrees. So to find angle B, all I gotta do is figure out what 180 degrees minus 110 degrees equals, and that's 70. So I'm just going to write that big underneath there so I know. 70. And if angle B is 70 degrees, the vertical angle to that over here should also be 70 degrees. But if you don't believe me, you could always cover up these guys and say, okay, 110 plus something, it makes a straight line. It's got to be 180 minus 110, which is, again, 70 degrees. I want you to notice when you add all four of these angles up, you put it in a calculator, or if you can do some good mental math or scratch work on the side, all four of them add up to 360 degrees. This number has come up with circles in the past, I think. People have mentioned it, so I know it's been brought up in classes before. But if I have all of the angles around an intersection, if I know all these measurements, they're going to add up to 360 degrees. So if I was only missing one of them, I didn't know anything else about it besides all the other angles, I just add them up and take that away from 360 to find what's missing. Like I said, if you want to pause it and give these a try real quick, go for it. I'm going to go ahead and start though. It wants to know what angle X is, and that's a vertical angle to 148, so it's 148 degrees. How do I know? It's a vertical angle. And look, the same thing on number 6. We'll get to that in a second. This one, I don't see any right angles. I don't see any straight angles. I see two different angles that are labeled. The 117 refers to the angle that starts there and goes over to here. And this 94 is the one that starts up here and goes to this here. And that's a lot like what happened on this page when we had to find the angle BFC. We know from angle AFC is 100, and if we look at angle AFB, we can measure that to be 40. So if I know this one, and I know the bigger one, I just gotta subtract and find the missing piece. So 117, oh, hold on, it wants an equation. So I know that my angle X plus my angle 94 adds up to 117 degrees. Let's say it's 23. Yep, 23 degrees. So it doesn't have to be a pair that adds to 180 or a pair that adds to 90. You could get something that adds up to something else. As long as you know either what they both add up to and one of them, or if you know what each individually are, you can find out the total angle. You got vertical angles again. X has to be 35 degrees because they're vertical angles. I'll pick it up in a minute after I get a drink of water or something.